Hi, today's topic is square root functions. The square root mother function is f of x equal to square root of x. The square root of a number is always positive. The square root of a negative number is imaginary. So these are some facts about square root functions that you need to know. The graph of f of x equals square root of x looks like this. If you substitute a couple of points to get an idea, if x is 0, the y would be square root of 0, which is 0. So that's 0, 0. We cannot substitute any negative numbers for x because square root of a negative number is imaginary. We're not, that's a different course. If x is equal to 1, we have square root of 1, which is equal to 1. So 1 comma 1 is a point. When x is 4, y is square root of 4, which is 2, and so on. These are the easy points to find because the x values here are perfect squares. Some important facts that you can notice about this graph is that its domain starts at x equal to 0 and it increases to infinity. It goes on forever because you could keep taking square roots of all the numbers forever. And on its domain, it's increasing. The y values are always increasing. And it's always concave down. It never goes concave up, always concave down. It has no max on minimum points, though I have to correct this because it actually has an absolute minimum point, which is 0, 0. I don't know what I was thinking. There you go. And the good thing is that this is really the only new concept here, this graph, which you can easily draw on your calculator. You can plot a couple of points and you can see where it is. You just have to memorize. You have to memorize the shape of it. It'll be a lot easier. And the rest of the facts about this, I know this looks overwhelming, but it's really all these facts that I'm listing here are the facts that are also holding for absolute value functions and parabolas. So all the shifts, all the stretches, reflections in the x-axis, they hold for all the functions we're going to learn about. So you're going to keep seeing these over and over again. So here are some examples. Here's what I'm trying to tell you. So if you know what the mother function looks like, square root of x, y equal to square root of x, then you should know what y equal to square root of x plus 4 equals. So if you're adding a number to a positive number, 4 in this case, to the function, you're increasing the y by 4, so your graph will shift up 4. The red function here is the original mother function, y equal to square root of x. And the blue one is this function up here. So notice how it is the same as the original, except it's just moved up 4. It's shifted up 4. And this one, before I uncover it, how is it going to compare to the original function? Got it. If when you added 4, the graph moved up. If you subtract 3, the graph will move down 3 units. Here we're changing the x, both in C and D, we're changing the x values. If you're adding 1 to x, that means your graph is going to move to the left 1. See, the blue one? It's moved to the left. This is going to be moved to the right 2. And if we are multiplying the function by a number bigger than 1, then the graph is going to be stretched in what direction? Do you remember? Vertically, that's right. And if the number we're multiplying by, if the coefficient is between 0 and 1, then the graph will be stretched horizontally. So it's almost as if someone's pulling it in the horizontal direction. If we're negating the function, then it will reflect in the x-axis. And that looks beautiful, and actually, yes, that is a sideways parabola. And that's all there is about this function.